So what we're going to do in this video, we're going to take the three unbalanced line currents of a star connection, and we're going to draw vectors which are lines with a certain direction for each of the line currents, the three line currents that are out of balance. And then we're going to resolve those vectors to find the current flowing through the neutral wire. The first thing to do is have a look at what the values of our currents are. So one phase is 10 amps, another phase is 20 amps, and the third phase is 15 amps. But all of these are 120 degrees out of phase with each other. So if we draw them to scale at the right angles, we'll be able to find out how long the line is that represents a neutral current, or how much the neutral current is. So I'm going to keep it simple. For a current in one of the phases at 10 amps, I'm going to draw a line vertically upwards as a starting point with a length of 10 centimeters. So 1 centimeter is 1 amp on my scale. So if I move the ruler out of the way, there it is. So that's 10 amps for the first phase. So that one's done. I'll choose a different colour. I won't use the proper colours because they're all pretty dull, but I'll use red for the second phase. So if I drew it here, it would be at 90 degrees to the first. So I need another 30 degrees, so it's 120 degrees out of phase. So I need my line to be at 90 degrees and another 30, or 120 degrees out of phase with the first one. And the second one is 20 amps. So that's going to be 20 centimeters long. So I'll start where the first one finishes, and I'll go down to 20 centimeters. So that's the second phase current done. And then the third one is a further 120 degrees out of phase than the second one was. So that means it's 240 degrees out of phase with the first one. So all I need to do is put the start of the ruler at the end of the last vector, and then I'll spin it a further 120 degrees. So this will say 150 on the ruler. Even though it's upside down, I can tell when it says 150. So that's, the first one was straight up pointing north. The second one was at 120 degrees, which is 30 degrees below the horizontal. So this is a further 120 degrees than the last one. So the length that I need for the third phase is 15 amps, which will be 15 centimeters for my third phase. So I'll draw the line up to 150 mil or 15 centimeters. This shows the unbalanced currents. And all we need to do to figure out the neutral current is connect the two open ends. So that looks pretty good. The neutral current I'll do in blue, which is actually the correct colour. And join them up. And if we did zoom in, we'd be able to see that the neutral current has a length of about 8.6, 8.7 amps, because it's 8.7 centimeters. So we can just say that I neutral is 8.7 amps. And that would be the same as if we worked it out using the trig formulas with all the squares and subtractions. And on Desmos, what I did earlier was have all of the different phases. So here's one phase which is at an amplitude of 15 amps. Even though they say volts, it doesn't matter. It's about the sine wave amplitudes that's important. So 15, this one peaks at 10, and this one peaks at 20, just like the three currents do. And when I add them all together to get the neutral current, that peaks at 8.66, this black one here, which is what we just worked out. So that's how you resolve vectors or phasors, which we call phase vectors, in order to find the neutral current in an unbalanced star connection.